Welcome to Engineering Studio with Dr. Mohammed Tahir. In this video, we are going to discuss about the equivalent lateral force procedure for earthquake load given by ASCE. So the equivalent lateral force procedure consists of the following steps. So the first step is estimate the effective seismic weight of the structure. So we need to estimate the weight of the structure which will be present at the event of earthquake at different levels of the structure. And the second step is to estimate the first mode natural period of the building. So the period of vibration of the building for only first mode mean if we displace the building in this direction and then release, so in how much time it will complete its one revolution. And choose the approximate seismic base shear coefficient. After that we need to select some seismic base shear coefficient based on the site condition, based on the type of the building, and based on the ground acceleration. Calculate the seismic design base shear. After that we need to calculate the seismic design base shear and then distribute the base shear as a component forces or as inertial forces acting at different level of the structure. Then we need to find these inertial forces from this base shear. Okay, once we have determined the inertial forces, then the next step is to analyze the structure under the design lateral forces to obtain design actions such as moment and shear. So at each level we can find the bending moment, and then we need to distribute this bending moment calculated at each level to the lateral force resisting system. Similarly, we can also find the shear force at each level, and the shear force calculated at any level need to be distributed over the lateral force resisting system. Finally, we can estimate the structural displacement, particularly the story drift. We can also find the story drift mean. For example, the building has 3-4 stories. How much is the lateral deflection of the top story with respect to the bottom story, or the deflection of this story with respect to its bottom story. So we can estimate the story drift. Okay, so now in this video we will also discuss about the effective seismic weight, that how we can estimate the effective seismic weight which is used for the equivalent lateral force procedure. So the seismic weight, effective seismic weight W, which can be calculated based on the ASCE section 9.5.3. So it is the effective seismic weight of the structure including the total dead load, so total dead load of the structure, and other load. Other loads can be in areas used for storage. A minimum of 25% of the floor live load need to be considered. Mean the W will be equal to total dead load plus 25% of live load in case of storage. If the building is used for storage, so in that case we need to consider 25% of the storage load or the live load for which the building is designed. Where an allowance for partition load is included in the floor load design, the actual partition weight or the minimum weight of 10 pounds per square feet need to be considered. So we also need to consider the load of partition. So if the actual load of partition is known, then we can take the actual load. Otherwise, we can consider this minimum value 10 pounds per square feet. Then this seismic weight will also include total operating weight of permanent equipment. If there is some permanent equipment in the building, so we need to consider the weight of that equipment. So equipment weight plus, in case of areas where there is snow and the roof is flat, so in that case we need to consider 20% of flat roof snow load, where flat roof snow load exceed 30 pounds per square feet. So in the areas where the snow load exceeds 30 pounds per square feet and the roof is flat, so in that case we need to consider this 20% snow load. So we can say plus 20% of snow load. So our total load or the effective seismic weight include all these type of loads. So we need to consider all these loads based on the actual situation of the building. So the approximate fundamental period TA, which can be calculated based on the ASCE section 9.5.5.3. So the fundamental period of the structure T in the direction under consideration shall be established using the structural properties and deformation characteristics of the resisting elements in a properly substantiated analysis. So based on the properties of the structure, based on the lateral force resisting system and its properties, we need to calculate the actual time period of the building by computer analysis or by using finite element analysis. But at the initial stage, before the design of the structure, we don't know the properties of the lateral force resisting system. So in that case, we can estimate the time period. So however, at initial stages, it can be estimated to calculate the seismic force by using following expressions. So at the initial stage, we can estimate its value, and its value can be estimated by using this equation. The approximate fundamental time period TA in second is given by TA is equal to Ct time Hn raised to power x. So here Hn is the height of the building in feet above the base to the highest level of the structure. So for example, we have a building and the ground level is over here. This is the ground level, and we have two basement plus 3, 4 or 5 stories as a superstructure. So in that case, Hn will be from the ground level up to the top. We do not consider the basement in the structure. Okay, so this will be Hx or Hn. And Ct and x, these are the coefficients which can be determined from the table given in ASCE code 9.5.5.3.2. So from this table we can select the Ct and x coefficients, and these are based on the type of structure. So for moment resisting frames of steel in which the frame resists 100% of the required seismic forces, so in that case we can consider this Ct is equal to 0.028 and x is equal to 0.8 if we are using FPS system. And if we are using SI system, so in that case the factor which is in the parenthesis, that will be considered. Similarly, for moment resisting frame of reinforced concrete structure, this value will be considered, and for eccentrically braced frames we can consider this value. So based on the type of structure we can select the Ct and x, and then we can calculate the time period of the structure. We can also approximate the fundamental time period of the structure in case of concrete and steel resisting frames by using this expression. T is equal to 0.1 time n, and here n is the number of stories, and this expression is only valid for up to 12 stories if the building have 12 stories and the height of the story is about 10 feet or 3 meter, mean it is more than 10 feet or 3 meter. So in that case we can use this expression to estimate the time period of the building. And if the building consists of concrete shear wall or masonry shear wall, so in that case we can approximate the time period by using this expression, and here Cw is a coefficient which is defined over here, and Hn is the height of the building from the ground level, total height of the building from the ground level. And if we see this Cw, so it has AB, Hn, Hi, Ai, Hi and Di. So we need to see what are these coefficients. So where AB is the base area of the structure, in whatsoever is the total base area of the structure. Ai is the area of shear wall. For example, we have shear wall over here. So shear wall 1 and shear wall 2. So the area of ith shear wall, first shear wall or second shear wall. Similarly, Di, the length of the shear wall. So Ai is the area of the shear wall and D is length of shear wall. Similarly, N is the number of shear walls in the buildings. For example, there are 2 shear walls, so N will be equal to 2. Effective in resisting lateral force in the direction under consideration. So for example, if we consider this direction, so this shear wall will be effective to resist the lateral forces. We need to consider this shear wall, and similarly in this direction this shear wall will be effective to resist the lateral forces. So based on the condition we can consider this N value. And similarly Hn is as defined earlier is the total height of the building, and Hi is the height of the ith shear wall. For example, if the height of this first shear wall is up to 2 stories out of the 3 stories, so we can consider this hi equal to the height of the 2 stories. For example, if the height of 1 story is 10 feet, so its height will be 20 feet. Okay, there is upper limit on the calculated time period. The fundamental building period to determine in a properly substantiated analysis shall not exceed the product of coefficients for upper limit on calculated CU. So the time period calculated based on the computer analysis, it should be less than TA, mean the estimated time period multiplied by this CU factor, which is the coefficient for upper limit on the calculated period. So based on the design spectral response acceleration, the value of CU is given. For example, if SD1 is 0.3, so in that case CU will be equal to 1.4. So T, the actual time period, should be less than T estimated times 1.4. So by using this expression, the previous 3 expression, we can calculate the time period with the suitable expression, and then we need to see its upper limit, that our actually calculated time period should be less than TA times CU.